You need a mix of like solar, wind, hydroelectric, and nuclear in order to meet energy demands. But nuclear is the most difficult one to understand. So I'm really encouraged that if students in high school are writing papers, they're reading a lot, they're learning a lot, and it's necessary. But the best part is that when you write these papers and you present them in class, you teach your fellow students. And this is when people become more aware of nuclear, not from some older professor like me, but through students the same age. That's the most important.
Oh, yeah, yeah. Okay, so how do you view that in the future the interstellar travels will be possible by harvesting the energy from the nuclear fusion reactions, like the deuterium with tritium or deuterium with helium-3?
Sure. So that might be possible, though we have a long way to go. And so first we have to harness that energy here on Earth, because we currently have no fusion power reactors. Now the needs will be a little different, right? Producing heat and thrust is a little bit different than producing electricity, but it still requires plasma confinement, harvesting the energy in an efficient way. And so I think it's in our future, but it's in our far future, as in there are more near-term viable deep space exploration technologies, but at the same time, nuclear propulsion is an active area of research, and it should be too.
Okay, so currently I'm writing a paper on a nuclear fusion propulsion. What do you think are the
Mhm.
most realistic and promising fusion propulsion concepts that I could tackle? Yeah, what do you think
Yeah,
about?
so there are a lot of fusion concepts from the magnetic confinement to inertial confinement to reversed field configuration, and then a few others. But the most promising ones to me have the lowest risk of the physics. And so to me, that would be the tokamak-like devices, basically anything shaped like a donut, whether this is a tokamak, a spherical tokamak, spherical spheromac, or a stellarator. And
Hmm.
so these devices, we've had 70 years of experience building physics test devices. We've refined the models of how plasma and confinement work. We've experimentally verified them using these test devices. And if all goes well in the next few years, these will be the first devices to hit what we call engineering break even. You may have heard that laser-based fusion at the US National Ignition Facility reached break even, producing more energy from fusion than they put in, but this is only if you draw the boundary of the system at the fusion fuel,
Hmm.
not at the outside of the building with the lasers and the power supplies. So the first technology to get there, that the engineering break even is likely going to be tokamak type. And therefore, I think that's going to be the most viable for anything fusion moving forward because we have the most experience, we understand the physics, and now really it's an engineering problem. And this is something we can solve slowly but surely.
Thank you very much. So, how can I balance learning theory with hands-on experience, with basically maybe projects? Are there ways to get involved in small-scale experiments without a lab? Because in Bukhara schools, the laboratories are
Mhm.
only available in presidential schools, but I'm not enrolled in the presidential school.
Sure. So I'd say there's a lot of work to be done on the research side, analyzing data coming from these physics test devices. So this is something where even remotely you can be asked to do data analysis from the data taken on experimental devices. In addition, the kind of thing that you can build yourself for not too much money. I mean, it takes a lot of money to build a tokamak, but you can build what's called an electrostatic fuser, which is a electrostatic pulsed or steady state machine that first generates a plasma, and then if you use deuterium fuel, you can actually create fusion in laboratory scale. I even have a student I'm working with who built this in his basement at home. Now, it's not incredibly cheap. Like the components might be a few $1,000s US, but this is in the realm of, let's say, a school or a bigger organization building, like a science club. Probably it's out of range of like a normal family, but this is something that a school could certainly invest in so that they could give their students hands-on experience. And because it lets you visualize electric fields in the plasma, it's perfect for hands-on teaching of basic electricity and magnetism, and also measurement of optical properties of plasma, so optical spectroscopy. So in addition to being a fusion machine, it's a great physics teaching device, and it's not that expensive to build if you build it yourself from the parts. Now, in my lab, actually, that same student is working on an open source version of an electrostatic fuser. So we hope to make this available in the next few months so that everybody can try to build one themselves.
Wow, That's great. Wow.
We
Okay.
did the same thing with a Geiger counter, a radiation measurement device. There are many kits for making Geiger counters for measuring radiation, but we completely open sourced it. We just said, go here to get the parts, give this file to a company to make the circuit board, you can do yourself because we want to democratize it or put it in the hands of all people.
Yeah, I think that's great. Okay. So what skills do you think will be most critical for the future of nuclear engineering or aerospace systems?
Sure. So it's interesting. If you look at the types of people that work at a nuclear fission plant, most of them are not nuclear engineers. In fact, there's only a small number of nuclear engineers at each plant, and then it's mostly mechanical engineers, chemists, electrical engineers, civil engineers, general engineers, but all of them working with some small nuclear specialty. So that's the nice thing. If you want to get involved in nuclear power, like if you want to design reactors, yeah, you should study physics and nuclear engineering. But if you want to contribute to nuclear power through a different specialty like material science or mechanical engineering, you can. Most of the people that work at a nuclear plant are not nuclear engineers, yet they take their degree, they gain a little bit of specialization, and then they're working on nuclear power.
Hmm. Got it. Okay, so now imagine that you're 15 years old right now and it's 2025. What would you do
Yep.
to focus, okay, what would you focus on in the next 3 years to stand out?
Sure. So in this case, I think if I were to pick a field and what to do in my free time, something like so if you enjoy the plasma physics side of things, applied physics would probably be the major to go in, right? Theoretical physics, you're talking about either like far off astrophysics or subatomic physics. This is not necessary for fusion power, so I would go into applied physics. But also, if you want to tackle the real engineering problems that are facing fusion power, the number one field to me is material science. Now, I may have a slight bias because I also have studied material science quite a lot. But when you think about what are the problems causing nuclear fission plants to have longer outages, what are the problems preventing nuclear fusion from just being built, they all have to do with plasma diagnostics and control, and especially materials of construction. There's a difference between building a fusion power plant that turns on day one and building a fusion power plant that lasts long enough to be economical. And the difference between those two is the materials of construction, radiation damage, corrosion, stresses, high heat fluxes, and all of these together. So if you really want to make a major personal contribution to the field of fusion, I would say either applied physics or more likely material science in the hands-on region.
Hmm. Understood.
It
Understood.
might come as kind of a surprise because we usually think of fusion as a physics field. And that's because until about 10 years ago, it really was just physics. It was very far off. Nobody thought we'd be building one of these very soon. And now there's all these startup companies that are promising to build some in the next few years, but they don't know what to build them out of. And at the end of the day, the reactors will be made out of materials, but we don't know what those materials are yet. And we have very little time to figure it out. So personally, if you want something exciting and fast-paced, I would do material science.
Understood. Okay, so in Uzbekistan, in Bukhara, including me, there are a lot of students who want to apply to MIT. So do you think
Mhm.
that there are ways that we could positively contribute to our application?
Yes. So the mentality, I've talked to a number of students in Uzbekistan and CIS countries, and the mentality of students is very influenced by the old Soviet academic system, which emphasizes high grades, high achievement, and basically doing what your teachers want. This is not what we're looking for at MIT. We don't want people with absolutely perfect grades that don't do anything else. The one thing we're looking for is called fire in the belly, which means this unquenchable passion, which means if you're given a certain set of resources, you create or develop new resources to do something new. For example, if you're at a school in Bukhara and you don't have any laboratory equipment and such, you find a way to get either a donation from some local rich guy or from some company to build this electrostatic fuser, show it off, and say, I did this without anybody's help, without any resources. I created my own future and realized it. And the same thing goes for after school clubs and activities. Many people think the more you have, the better. This is incorrect. What we're looking for is for each kid to do one or two or three, but they really excel at it, right? We go deep, not broad. We don't want people that just get perfect grades and don't do anything new. And we don't want people that do 55 different clubs and sports and activities because you can't do any one of them very well. Even if you can, we'd rather you show incredible depth, leadership in a field, leadership of a community. And that takes time. So showing that you manage your time by going deep instead of broad, like sometimes people ask me, what's the correct number of after school activities to get into MIT? And the number may surprise you, it's one. You do one thing really, really, really well and spend all your time and passion on it. That will give you the best chance.
Wow, okay. That sounded very unexpected because from what I heard, yeah,
Hmm.
it was kind of a reverse. Like you have many school activities, right, through which you can show different skills. Understood. Thank you very much. Okay.
Exactly, yeah. And it's very unexpected for most students that are not from like US, Canada, UK area because achievement is often measured in numbers in the rest of the world. We measure achievement in impact. Is in,
Mhm.
okay, you can achieve many things in numbers, but what did you do to help people? Who did you help? How did you help them?
Mhm.
That more impact comes from more depth, more deep contributions, lots of time and thought, rather than splitting your time among many different activities, because it's a hallmark of good time management.
Okay. So I've been thinking about, in fact, since last year summer, I was thinking about building a particle smasher. Like in my pipe dreams, I was like, okay, if I built it, I could show it to my
Mhm.
friends. I could make it in like in my summertime. But
Mhm.
what really halted this process is the fact that first of all, we didn't have funding, and second of all, we didn't have resources. But now I'm thinking about that. What if everything is indeed possible, but we should just go a little bit deeper into it? Like we should research and we should search for the, as you said, donations, right? Hmm.
Mhm.
Okay, so what
Yeah.
is, yeah,
So, I
yeah.
mean, for example, there are very cheap ways of making electron linear accelerators, right? It may not be a particle smasher like CERN, but you can still build an accelerator that fits on the tabletop with extremely basic tools. So, for example, I built one out of just sort of sheets of aluminum metal, resistors, some vacuum components, so like some metal chamber. And then usually the expensive part is the high voltage power supply. But
Mhm.
you can research how did people in the 1920s and 30s build these power supplies before there was all of this, integrated circuits and things. And so it turns out that you can build what's called a Van de Graaff generator, which means that if you have a belt of insulating material like rubber that you rub onto an electrode, you can even power it with a bicycle. And you can generate enormous voltages on a Van de Graaff generator and then use that with voltage and resistor to accelerate electrons and make an electron linear accelerator, which you can then characterize. So the one most expensive part, if you want to think, how do I build it with very few resources? Look to see what people did in the 1910s, 20s, and 30s when none of this technology existed. And you'll actually find, not exactly, but close to like bicycle powered, pedal powered accelerators. You can do this. And if you document it, catalog it, it'll be really impressive to build your engineering portfolio.
Wow. Okay, understood. Understood. Okay.
So I think what you wanted to do, you can do it. It takes surprisingly little equipment and money if you're smart about it.
Understood. Okay, got it. Do you think that there are some other ways to show my engineering passion, right? Because
Mhm.
again, with little funding, because the money
Mhm.
is kind of big issue here in Uzbekistan. So what do you
Mhm.
advise?
Yeah. So other ways, like aside from, let's say, building something new, other ways you can show your engineering passion. Something I did as a student was repair of electronic devices, where most people throw out electronic devices when they break, but oftentimes it's something as simple as a blown fuse on the board or a busted transistor or something. And so that way, if you get known as someone, they bring their equipment to you. You can figure out how to repair it. It shows that you're learning the electrical engineering, you're learning the soldering skills, you're learning how to debug things. And that general skill of debugging is one of the most important skills in engineering. So if you're able to talk that way, people bring expensive things to you, like expensive things that they bought, they think are broken. You're then contributing to not just recycling, but upcycling. So it's good for the environment, it's good for your wallet. Maybe you can get paid to do it, but you can also reflect and talk about the electrical and mechanical engineering skills you had to learn in order to debug these things. And showing that you're able to debug means, okay, if someone presents you some problem, you can figure out how to fix it, whatever it is. That's really important.
Wow, understood. Got it. Thank you very much. Okay. It was a pretty nice talk. In fact, I really enjoyed it. I really got something new from you, you know. Yeah.
Glad
Um,
to hear.
yeah. So you said that you're gonna come here in August, right?
Yeah,
Bukhara.
probably the week of August 18th, I'll be coming to Samarkand and Bukhara. So I don't know exactly which day where then, but it'd be great to meet up because
Yeah.
I'll be in the air.
Okay, sure. Thank you very much. Okay.
So, and if you want to bring some other folks too, like if they have questions they want answered, I'll be happy to explain, meet some of the other folks that you're talking to.
Okay, sure. Got it. I will certainly do that because in Bukhara, I've got one of my friends who has been just crazy about the quantum mechanics, and he also learned a lot
Mhm.
from a lot from the nuclear physics, because I
Mhm.
mean, in my community, which basically I kind of started because in Bukhara the science isn't considered to be important, and I think that this is disgraceful. I think that science should be available to anyone, and that just fascinating field in that we have to go deep into, especially advanced physics like nuclear physics, right? And I've got
Mhm.
a lot of friends here, who are really interested in
Cool.
nuclear physics, right? And we've been studying kind of on a very much theoretical level when we
Mhm.
were kids, right? Such as analyzing the standard model or thinking about the general and the special relativity, mainly the theoretical stuff. And
Mhm.
and then when we just found out that there are institutions out there in the US that focus on this field in a very, very deep sense, and that they are basically making groundbreaking researches. We're totally fascinated about it, and
Cool.
basically, yeah, this is one of the basic reasons why I contacted you, and I wanted to learn
Mhm.
a lot from you, especially because you're the person who are connected to MIT, right?
Mhm.
And I hope that in the future I'll also contribute much to the field because that's gonna be just a pretty amazing life if I do this. Yeah,
Absolutely. Yeah, I'd love to help you get where you want to go.
yeah. Thanks. Thank you very much. It was a nice talk.
My pleasure. Yeah. Let me know if you want to talk again, and otherwise we'll hopefully get to meet up in August.
Yeah. So, do you think that apart from building and making up these incredible devices like the as you mentioned linear electron accelerator or the electrostatic fusor, do you think that there are
Mhm.
some other ways I could also grow intellectually, right? Just not connected to admissions, but for myself, personally grow intellectually.
Yes. In fact, so now since I've been a teacher of nuclear physics and engineering for 12 years, and I used to do a lot of tutoring, I can tell you that the best way to learn is to teach. It's a far, far more effective way to learn because when you sign up to teach something, something triggers in your brain and you realize, oh man, I have to be able to ready answer any question from all these smart students, maybe even smarter than me. The only thing I have on them is experience. And so volunteering or signing up to teach modules on advanced physics to even kids in your area will require you to develop the skills to answer all the questions, and the questions you get will get you thinking in new ways. And I'd say that from, I got 4 degrees from MIT. I did a lot of studying on my own, but the most learning I did is by teaching the students at MIT. And because they ask me the most insane questions and I have to do research to figure out the answers, that's what I recommend for you.
Thank you very
So
much. In
find
fact,
ways of, yeah, find ways of being asked to teach enrichment modules, advanced physics, basic physics to anyone who's interested. And you'll find that you start learning at a tremendous speed, faster than you could on your own.
wow. Okay. In fact, I'm teaching myself. It was
Mhm.
pretty cool to get a confirmation that it really helps. I basically teach students at advanced maths because
Hmm.
students in Bukhara, let's just say that education is not on a very, very good level, especially when it
Hmm.
comes to teaching math in English. You know, like
Hmm.
SAT, AP Calculus, and others, right? It's it has very high demand, but there are there is a scarcity of teachers who can teach it. But as a student, as a person who knows it, it's
Hmm.
been like pretty long time. Like I started in September. I've been teaching pretty old people, by the way, like those who are older
Cool.
than because I'm 2009 and there are students who are 2006. And
Hmm.
I can certainly say that yes, 1,000,000%, it certainly helps to basically learn a lot from math. Like maybe there are some certain parts that I didn't know about integration. Now I know about it, right? Like
Nice.
integration with trigonometric substitution, right? Like
Hmm.
such as I teach, I gain experience. I teach someone, I help someone. It's for a better cause, right? And I think that
Hmm.
yeah, maybe teaching physics in summer that would be pretty cool too. This way I could help others to learn physics in English, right? Which is
Hmm.
not that popular, but I think that the most important, the best way to learn physics is to learn physics in English because I mean most of the discoveries were made in English, so it's kind of pretty cool to know it in English too. Yeah,
Sure.
yeah.
It's funny. I'm kind of lucky that I'm a native English speaker because 100 years ago, the language to learn the science was German. And so if you
Mm,
wanted to learn science, you also had to learn High German. And then it's changed to English over time.
yeah,
And
yeah.
who knows, maybe in 100 years, it's going to be Chinese. Like we don't know